Today we are going to discuss an important topic of pharmaceutical chemistry 1 organic, which is conformational analysis. So here we have conformational analysis. The conformational analysis is defined as the analysis in which the three-dimensional spatial arrangement of atoms or groups around the single bonded carbon atom such that their dihedral angles are specified and their relative energies are known. So this is the definition of conformational analysis, and here are three things. Number one is three-dimensional arrangement of groups. Number two is their dihedral angles are specified, and number three is their relative energies are known. So when these three conditions are satisfied, we will say that we know the conformation of the compound. Remember that there are three methods to represent a molecule or a structure. First one is called as Newmans projection. Second one is called as Sahor's projection, and third one is line and wedge projection. So these are the three types of projections with the help of which you can represent any structure in three-dimensional form. First of all, we will discuss Newman's projection. In Newman's projection, न्यूमॉन्स प्रोजेक्शन के अंदर बेसिकली हम क्या करते हैं कि कोई भी अपना डिजायर्ड बॉन्ड सेलेक्ट कर लेते हैं. मिसाल के तौर पर हम एक मॉलिक्यूल ले लेते हैं CH3 सिंगल बॉन्ड CH3. ये हमारे पास एक सिंपल सा मॉलिक्यूल है. दिस इज द सिंपलेस्ट मॉलिक्यूल which is ethane. Now, in Newman's projection, we will select two carbon atoms. One will be the nearer to the reader and the other will be rarer to the reader, and we will visualize this molecule from this side, not from in the direction of the pointer, but in the direction from here, which means that this carbon will be towards the reader and this carbon will be nearer to the reader. Or you can imagine the opposite by visualizing from here. Let's open up this structure. We will open up this structure and write up in this form. Now we have done two things. Number one, we have taken our simplest structure, and secondly, we have opened up this structure. Now imagine that we are visualizing this structure from here. So how will we visualize it? So if we visualize it from here, you can see that this carbon atom will be nearer to the reader, which means it will be just towards the reader, facing the reader, and this will be far away from the reader. So the carbon atom which is nearer to the reader will be drawn from the center, and we will